In this video, we're going to be looking at examples of inequalities that need integer solutions this time. Now, integer means whole number, and it's the word integer that you'll probably see in the exam paper rather than whole number, because it's the correct word to use. So, for the first one, we have 2, which is less than or equal to 3n plus 7, which is less than or equal to 14. Now, what we need to do is we need to work it out, so in the end we've got n on its own, because that's our unknown at the moment. So, we're going to work on this middle bit here. And while we're working on that middle bit, we need to keep it all balanced. So we can take things away and add things and stuff to all the different sections all at once. So I'll show you what I mean. So we've got 3n plus 7 and I want to get n on its own. So what do I do first? Well, I need to get rid of that plus 7. So to all three bits, I'm going to do the inverse of plus 7, which is minus 7. So 2 minus 7 is minus 5, which is less than or equal to 3m plus 7 minus 7 is just 3m, which is less than or equal to 14 minus 7, which is 7. Okay, now I still want my n on its own, so I need to get rid of the times 3. And to get rid of times 3, I'm going to divide by 3. And again, that's something that I have to do to all three bits. So we're going to end up with minus 5 over 3, which is less than or equal to 3n divided by 3 is n, which is less than or equal to 7 over 3. Okay, now the last thing we want to do is put these fractions as mixed numbers. So that's minus, and then it's going to be 1 2/3, which is less than or equal to n, which is less than or equal to 2 1/3. Okay, now, because the question asks us to find the integer values of n, we need to have a look and see which whole numbers n can be. Because we know that n can be anything between minus 1 2/3 all the way up to 2 1/3. But we know it can only be whole numbers, okay, because the word integer is used. So I'm going to go to my number line and I'm going to just put a little cross at each of these things. So minus 1 2/3 is going to be about there. And 2 1/3 is going to be about there. So which whole numbers can it be? Well, it can be minus 1, 0, 1 and 2. So at the end, we're going to put n can equal, and then we're going to put minus 1, 0, 1 and 2. Because those are all the different numbers, all the different integers that n can be. If we move on to our next example, it says find the largest integer value of n if 2n plus 3 is less than or equal to 12. So what I need to do here is just solve this question. So I've got 2n plus 3 and I want to get rid of the plus 3, so I'm going to do minus 3 to both sides. So that gives me 2n, which is less than or equal to 9. Now I want to get rid of my times 2, so I'm going to divide by 2. So I've left with n, which is less than or equal to 9 over 2. And I'm going to rewrite that because it's an improper fraction at the moment. So if we make it a mixed number, 9 over 2 is the same as 4 1/2. So now I need to find the largest integer value of n. So that's the largest whole number that this can that satisfies this inequality. So I'm going to go up to my number line and put a point at 4 1/2. And then I need to have a look and think what the largest whole number n can be. Now it can't be 5 because that's bigger than 4 1/2, and I know that n needs to be smaller. So it's going to be here. It's going to be n equals 4. And that's going to be the answer for that example.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.